Welcome back, folks. Next up, Sébastien and Andy will be leading us down the path towards Spring Boot native applications. Sébastien and Andy, take it away.
Thanks. So I'm Sébastien Deleuze. I'm a Spring Framework committer. I also work on the Kotlin support in the various Spring projects. Andy, would you like to introduce yourself?
Yeah, thanks, Sébastien. I'm Andy Clement. I'm a director on the Spring engineering team. I have created things in the past like Spell, but right now I'm focused on native images.
Okay, note that you can join the Spring One Slack in order to discuss. I have put the name of the channel at the bottom of this slide. So this is just a standard statement because what we are going to present here may and will change because that's all R&D work, currently work in progress. So today's agenda is the following. We are going to start talking about native application with GraalVM. We are going then to talk about the Spring Boot aspects. What is the current status? Andy will show you how you can getting started with compiling your Spring Boot application into a native executable. Then we'll follow a demo, more details about the Spring GraalVM Native projects, and I will share a glimpse of the roadmap. So let's talk about native applications first. GraalVM is a project started several years ago by Oracle. It allows, among other things, to compile Java or Kotlin or other JVM application to a native executable that does not require a JVM in order to run. That's pretty useful to create lightweight container images. The two main benefits are instant startup and reduced memory consumption. Instant startup is useful to achieve scale to zero capabilities. That means your application, when it will not be used, will be shut down. You will only pay when your application is used. And it's a kind of serverless, but not restricted to function. You don't have to change all your programming model. It's serverless for any kind of workload, including your regular web applications. And in terms of platform, if you are using a Knative, for example, that's a good fit because Knative will start your container only when you are receiving some requests. The other aspect is reduced memory consumptions. We observe between 3x and 5x memory reduction. I'm talking about the total memories, RSS memory. That means you will be able to have cheaper cloud instances, and that's also important for the sustainability, and we are very interested into increasing the sustainability of the Spring Boot applications. That's critical for systems split in multiple microservices because the minimal amount of memory is usually an issue with JVM issues when you split everything into multiple microservices. While those new capabilities are super exciting, we need to keep in mind that JVM and native executable have different trade-offs. So while native applications shine in terms of startup and memory footprints, they will offer generally slower performances. Notice that the GraalVM Enterprise provide performances-oriented features like better garbage collector inspired from J1 or some runtime optimization. But generally, expect a little bit slightly slower performances. Of course, GraalVM Native is less mature than the JVM, which is here for a very long time, but it progressed quite quickly. The big difference is in terms of build. So building a native application will take much more time and will consume much more resources. So that's typically will happen in your CI, and don't expect to use native application when you are doing some very fast development cycle. You will continue to develop with the JVM, and then compiling to native will be some kind of optimization to develop efficiently to containers. Let's talk about the key differences between the JVM and native applications. When you compile your application into native, there will be a static analysis done by GraalVM native image compiler of your application from the main entry point. Then it will analyze everything to only include what you explicitly use. Everything else will be removed. The configuration required is for reflection, proxies, and resources. So don't expect your JVM application will run out of the box. It requires some explicit configuration. The class path is fixed at build time, but that's not really an issue for us because Spring Boot, most of the Spring Boot application already use a fixed class path after the compilation. There is no class lazy loading, so everything shipped in the native application will be loaded in memory. Hence, the need to remove everything you can during the build. And some code will run at build time. Typically, some classes will be initialized at build time as an optimization. And so the static initialization of those classes could run during the build. I think GraalVM Native is a source of inspiration for the GVM ecosystem because it provides new capabilities to run your Spring Boot, your GVM application, and it focuses much more on the build time step with some optimization here. So I think that's a great thing. That's also, I think, a source of inspiration for the GDK team itself, because Oracle has recently announced Project Leyden. So Project Leyden is basically the same kind of ahead-of-time compilation, but directly supported in the GDK and in OpenGDK. Project Leyden and GraalVM are two different projects, but I hope and think that they will share some common goal and maybe some common effort together. GraalVM 20.2 has been released mid-August. It provides better static container image support, faster image generation, especially for big projects, and the Java classes that were previously initialized at build time are now initialized at runtime. And that provides better compatibility, basically, and avoid too much differences in terms of behavior between the GVM and the native application. Only available in the Enterprise Edition, there is a new garbage collector, like I said previously, and more runtime optimization. GraalVM Native is still in early adopter mode, so don't be afraid. That means that officially supported by Oracle, but with breaking changes. And we think it's mature pretty quickly, and the Spring team consider that in a few months, it will be mature enough to run your Spring Boot application in production. So let's now talk about Spring Boot native applications. I think GraalVM Native and this kind of ahead-of-time native compilation is a good fit with Spring Boot standalone deployment model, especially when deployed as a container. Compiling your Spring Boot application, like any other non-trivial application, to native executable will require some reflection, some proxy, and some resources configuration. But I have a good news. The Spring team, Andy, I, and others are doing the hard work instead of you. And our goal is really to support you, to compile your Spring Boot application unchanged. So the goal is to support your existing and future Spring Boot application without require too much modification. Okay, so good. Yeah, next slide, please. We have been collaborating intensively with the GraalVM team. Here is a quote from Thomas Voswinger, the GraalVM project lead. He said, we are excited about the great partnership between the Spring and the GraalVM engineering teams to support native ahead-of-time compilation for millions of Spring Boot applications. This is a game changer, enabling low memory footprint and instant startup for those workloads. And I would like to thank Thomas and the whole GraalVM team. The efficient collaboration we had this last month was very, very important, and we plan to continue this collaborative work in the upcoming months. The way we intend to leverage Spring Boot native applications, it's mainly and by default using Spring Boot container image support. So basically, you will configure your project in Maven or Gradle to say, okay, I want to enable native applications. And then when you will run Maven, Spring Boot build image, or the similar Gradle command, it will build a native application and it will ship it into a lightweight container. And I would like to thank especially Ben Hale and Emily Kazay for their work for supporting GraalVM native applications and especially Spring Boot ones in Paketo build packs using lightweight container. That's thanks for them. We have great support for that. So the end result is this kind of container image where you have the base container containing a very lightweight OS, so only 18 megabytes. It's basically a very lightweight Ubuntu consisting of only 7 packages optimized for security and size because the attack surface is very small. And on top of that, we add the native application, which is a standalone executable. Its size here is for a typical Spring MVC plus Tomcat plus Jackson, 47 megabytes, and the end result is a very small container image that starts instantly and consumes very low resources. Andy?
Thank you, Sébastien. So now we're going to spend a little bit of time exploring where we are in these projects right now, development methodology, and then I'm going to get to grips with how you can get out and try this right now. So you may have seen this slide yesterday in the keynote from Sébastien. Basically, we're looking at a timeline of where we are now. And I feel if you looked at the project a year ago, you would have seen that perhaps our troubleshooting section was the longest section of the docs. There was a lot of things to work around, or if you hit this crash, do this, or if you import this dependency, you need to exclude this transitive dependency. And as Sébastien mentioned, we've done a lot of work with the GraalVM team to get rid of all of that. Things are in a much better state now, and a lot of things will just work. So the relationship we've got with the GraalVM team, check out their GitHub. We have our own label on there for the issues that we have. What I'm trying to say here is that we've done a lot of work, but there is still some work to be done. I encourage you, if you hit a Graal issue, jump on here and see if some other people are hitting it. There may be a dev build with a fix in already, or you might be able to share a scenario use case or test case with them to help them debug it. And at the same time, as we got to a stable base with GraalVM, we've been working on incubating, and incubating is the key word here, support for Spring Boot applications in this Spring GraalVM Native project. If you're not aware of that, it's a project in our Spring Projects Experimental org, which is a place where we work on projects that aren't fully baked yet, but we're in full R&D mode on this project. I encourage you to take a look. There's a lot of documentation there on how to get started with it, how to use it, how to extend it. And there's a lot of pointers to the samples in there, so you can play around with the different technologies in Spring and building native images from those. So what really is this project? Basically, it's a plugin for the GraalVM Native Image Builder. And its job is to tell that native image builder about the configuration your application will need to run successfully. So it is analyzing your app and it's saying, oh, you need access to this resource or these reflection of access to these types or this proxy to exist. And it tells native image builder that so that it's all included in the image and you don't have to worry about it. Now, the challenge we face is we run in a static context there. We're not running the application, we're just observing it, looking at it, the state of it. And that does mean that sometimes there are things in it and we're not sure if you're going to use something. You can't tell if it's going to be active at runtime. So we have to err on the side of caution and add that configuration to the image. So that's a shame because if you don't use it, you're paying a price in that image. So we've done a lot of work on trying to compute the most optimal configuration. We're way better than we were, but there's still more work to be done there. We also, with this project, tweak your app as it goes into that executable because there are decisions we can make at build time to optimize it. For example, this is the one I often use. Spring includes lots of auto configurations. Those typically have a conditional on class annotation on them to indicate whether they should be active or not. And as Sébastien said, at build time of these images, the class path is fixed. Nothing can change after that. So conditional on class can be evaluated at build time. And that means we can throw away auto configurations when the image is built. And the runtime doesn't need to even go checking them to see if they're valid because they know they never will be. So those are fully discarded. The other thing we do is ensure your app is as compatible as we can. GraalVM has a mechanism called substitutions, which is like a patching mechanism for classes. So as you build the native image, you can patch the classes to slightly tweak the behavior. There's a couple of reasons you might do that. It might be to work around a GraalVM limitation. It doesn't support everything you can do in Java. It's documented on their website what is and isn't supported. So we may need to patch around something temporarily whilst we work with that, the provider of that original code to try and fix the problem. And we also may be trying out, and this is where incubating comes in, we might be trying out an optimization on a Spring class, saying if Spring did things this way, would it create a more optimal image? So rather than patching and rebuilding Spring, we just do a quick substitution here to test out an idea. And the aim is that when we've tested it out, we push it on down into those the library that supplies that code originally. So we've just released 0.8 of Spring GraalVM Native. It needs GraalVM 20.2 that Sébastien mentioned is just out right now. You do need to be on a Spring Boot milestone for this. You need to come, if you want to be on the bleeding edge, you need to bleed with us on the 2.4.0 latest milestone. It's M2 right now, but we're going to keep up with the milestones as they come through. And what's in there? Well, we've focused on two main areas, I guess. We have significant footprint improvements. I'm going to show you some numbers later that reinforce that. And there's a wider range of supported technologies. I'll show you some of the samples we've got now. We have many more than we did last time. There is a key new experimental feature around something called functional mode, and that relates to using functional bean registration rather than annotation-based configuration for your apps. Sebastian's going to go into that later, but it looks very promising. Then finally, a key feature was, as Sebastian showed, we've got this mechanism for integrating into the Spring Boot container image support, a very easy way to build optimized containers containing your compiled executables. And that can just drop into your Maven or Gradle build scripts. As I say, the plan is to chase Spring Boot 2.4.0. So we expect to fast follow the releases M3 RC1 through to the release of Spring Boot in November. And at that time, we expect GraalVM 20.3 to be out. And of course, we'll pick that up. I mentioned a wider range of technologies now working. Actuators now work. You see R2DBC now works. In fact, a whole range of Spring Data stuff has started coming to life. We've done a lot of work around web, particularly around Tomcat, as you'll see later. And Wavefront is now supported. I think you may have seen that in a talk earlier that I didn't see. And finally, if you're interested in those serverless use cases, there are some samples that use Spring Cloud Function. There are some Function AWS samples. So if you want to see that kind of scale to zero instant startup in relation to serverless, there's some samples you can explore there. So that was the Spring GraalVM Native project where we're working right now. And as I say, and it kind of hints at it with this "we are here" line, we're trying to push anything we incubate, things we learn, ideas, techniques that work for native images down into Spring Boot and Spring Framework. We expect that work to increase over time. So yes, there are already changes in Spring Boot related to native images. It's not all being done in Spring GraalVM Native. To show you that, a good example of that is the logging system. So this is Spring Boot 2.3, how it initializes logging. And you'll see here, there's a sea of strings, and you and I can tell that these are type names. But the GraalVM static analyzer, looking at this, it doesn't, unless it took a guess, it doesn't know their strings, their types, because everything in some map of string to string, it can't work it out. So effectively, to use this code, we have to, with Boot 2.3, we have to supply a bunch of reflection configuration into the native executable so that Spring will be able to reflect on these. And what it's trying to do is saying, if this key type is around, then this is the logging system to use. So it needs reflective access to check the existence of this, then reflective access to build an instance of this. This is not great. There is a better way. So if you look at what we do in 2.4, we're much more explicit that these are types. So you see, we are calling out now that we are checking for the presence of a type. It's a fixed string, and the analyzer in GraalVM can tell you, it can work out that is present is going to be a for name call underneath. So we are checking for the presence of a type. And we're not just returning a string now, we're returning a constructor reference. So it also knows this is a type. So now we don't need to apply any reflective configuration for this code. But taking a step further, because of the fixed class path nature of building a native image, we can evaluate this code at build time. And a lot of this stuff can just be discarded as irrelevant. Effectively, we can work out the logging system we need at build time, not runtime. So less code in the native image related to that, less code related to that reflection configuration. And we expect to see much more of this going on as we go through Boot and the other portfolio projects ahead. What else have we got? So we also have this option, if you're not using XML, you can turn it off. This is something we incubated and then pushed down into base Spring. We want to get to a world, obviously, where these flags are set for you and we do the right thing for you automatically. Not quite there yet, so you can turn these things on and off yourself. You will save 3.6 meg RSS. What is RSS? It's a measure we use of the memory used by the running process. So it's everything that the JVM is using, all the heap and the extraneous memory around that. Is 3.6 a lot? Well, if you're running a regular app on a JDK, it's not a huge percentage. But when you look at these native images, which are using much less memory, like tens of meg rather than hundreds of meg, it is a significant percentage, and these things add up. There's another one around spell right now. Save half a meg if you're not using spell. We have some grander plans around spell because, in case you're not aware, there is a spell compiler already in Spring Framework that we can exploit. So we may choose to start running that spell compilation at build time. rather than runtime, so we need much less reflective configuration there. And it's not just framework and boot. We've been doing a lot of work with other projects, and for example, Tomcat here. So does exist now in the experimental group ID, a Tomcat embed programmatic artifact. Now this is a stripped down Tomcat that suits our needs, and it's much easier to analyze by that GraalVM static analyzer. This will save you another 3.5 meg RSS. And remember 3.5 meg on the previous slide. It does start to add up. Can you use this right now in your apps? It's not quite fully baked yet, but it's a work in progress, but we expect it to be a real thing in the not too distant future. You'll see some of our samples are already using it if you start playing around with those. So that's how we're working with the projects, really. We are using Spring GraalVM Native to bake ideas and pushing them down into Boot and Framework, whilst at the same time working with the GraalVM team to make it a much smoother experience. But how can you use this thing? You can go to start.spring.io, as everybody should. The key thing will be to select that 2.4.0M2, because you need to be on 2.4. Or you can bring your existing project. The steps after this are kind of the same in either case. You need to make sure you're on that milestone of Boot 2.4. So upgrade your own app, or obviously the one we selected there from start.spring.io will be correct. And this is a pain point that we're going to work on a little bit, but you do need to set this proxy bean methods equals false attribute on your configuration classes. That is because GraalVM supports only JDK proxies. It doesn't support CGlib proxies. And by default, Spring will create CGlib proxies for configuration classes. So this turns off that behavior. So I've only shown it on this one class here because this is the app I generated from start.spring.io. In your own app, you will have to make those changes. But I will say that any dependencies you have on Spring projects, you don't have to worry about those. Proxy bean methods equals false has already been done in all of those projects. Then you need to plug into this Spring Boot container image support. So this is the snippet of code you need to plug in. It's very simple. There are other parameters you can supply if you need to. We'll see an example of that in a moment. But this is the minimum you can get away with, which simply switches it to saying, I want a native image for this when it's packaged in the container. Now that snippet and the Paketo build pack that we're using there will pull in a default version of Spring GraalVM Native, but it may not be the latest. So if you choose to, you can override the one that it's going to include by putting the dependency directly in your project. This is what I would put to pull in that 0.8 release. But in the future, you might want to grab snapshots. So you would use it in your POM to override what the build pack is going to use. Then building it is very simple, as we saw from Madura yesterday in the keynote. MBN Spring Boot build image. That will can take a while, 60 seconds for this app, and you will end up with a container. Now, a key benefit here is you don't need GraalVM installed locally for this to work. You do need Docker installed locally. The build will happen inside a container and produces a container, which then you can choose to run however you wish. Docker run, Docker compose. Here you see we're doing some port mapping to play around with this locally. And you'll get that 50 millisecond startup time in this example. You don't have to use Docker if you're more comfortable just directly doing those native image builds on your machine. There is a Maven snippet that you can paste into your build script. This is using the GraalVM native image Maven plugin. The key thing to specify here is the main class, the entry point to your application. Again, there is other configuration you can pass in here, which configures the behavior of Spring GraalVM Native or native image itself. But by default, we try and do the right thing out of the box, so you don't need to worry about that. We typically wrap this snippet up in a profile because we don't want to be doing native image builds every time you package the app necessarily. So this is the command that we would use if we wrap that up in a native profile, mbn-p native clean package. So this is a slightly different. You do need a GraalVM installed locally. It's available for Linux, Mac, and Windows, and the build will happen directly on your host. It will produce an executable for the platform you're on. So you can't be on Windows and ask for a Mac executable. No cross-compilation there. Seen a lot of success here with teams that are building Spring Boot CLIs. So they've crafted their CLI and they want something snappy that starts instantly. So they will just drop in that Maven snippet and then do a native build like this. It's Maven. It's just dump the output into your target folder. You can run it directly. This is the name that gets generated based on the main class. You can override that with the name if you have a preference. So that's all slideware, but I wanted to show something a little more real. Let me get out of this. So I'm on the command line and I'm in Spring Graal Native. I'm in the samples folder. So if you get a chance, you want to play around, these are the different technologies currently supported in the samples. As I say, the actuators in there, various Tomcat, Spring Cloud Function, AWS is in there, some Webflux R2DBC. So I encourage you to take a look at that. We're just going to have a quick look at one of the samples. This is Command Line Runner. It's very much a sanity test for us. This is a very minimal app that just exercises annotation-based configuration. So I hope you can see that. Basically, we have a single component that is just a Command Line Runner component, prints the message and then exits. So I'm not going to build that for you because watching it 60 seconds and nothing happening is not very interesting. But it is here for me to run, just to show you that it runs. Yeah, it's running faster than the 50 milliseconds we talked about, down in the 30s. So you have got that true instant startup feeling for this application. But that's just a toy. So let's look at something a little more real. So this is a Pet Clinic JDBC sample that we have that you can go and look at. There's only a couple of things I'll highlight in the POM for this project. So if we jump up to the top, I hope the stream is keeping up with scrolling. So we're on that milestone that I talked about that we need, boot 240M2. We've got that dependency on 0.8.0 that we want to use in the build pack. And we've also got that build pack snippet down here. On screen so it catches up. So here you can see that snippet I showed you before for using native image. We are supplying parameters here. So you'll see we're supplying this one that goes to Spring GraalVM Native, Spring Native remove YAML support. This is another thing we're baking, like that remove XML one. Like if you're not using YAML, then you don't need to pay the price for the parsers and so on. I don't know how we found an app without YAML in 2020. This is an option that goes to native image itself, and it says, I'm doing a little more with security. So I need you to include all the infrastructure for Java security in the image. So again, I don't want you to have to sit through a build because it's not that fun, but I wanted to highlight some things you'll see in there. So here you can see the build image stage. This was run with MVN Spring Boot build image, building that Pet Clinic thing. You can see the build packs have taken over. They pulled in the native image construction. And just down here, you'll see that it does show you the native image command it's using to build the application. So if you need to debug this later locally, try and work out if there's a problem, what's going on, you can run that locally and recreate what the builder's doing. I'll show you here. We can see, of course, we've got ASCII art, key part of the project. Here you can see that we are getting involved in the process for building the native image. This indicates the plugin in Spring GraalVM Native has started, and we're going to be doing analysis of your application. And the last thing I'll show down here is that it took 3.5 minutes in this case. You may think that's a long time, but believe me, it used to take longer than that. And it produced this Pet Clinic JDBC Docker container. So now I'm going to show it running. We have a Docker Compose file here. We need a MySQL running. I've already got that part of the Docker Compose running here. So we're just going to start the Pet Clinic part of this. Pet Clinic JDBC. So that was 200 milliseconds. Just going to start it a couple of times. So that's looking like 220 milliseconds. Not streaming at the same time. I've seen it go down below 200 a little bit. Does it work? Let's visit that. Yeah, it's just your regular Pet Clinic, as you'd expect to see. Okay, so back to slides. That was just to show you that it is real and the things I'm saying are true. Just to ground that a little bit in reality, how does that compare to running it regularly on a JDK? So clearly you're paying a price here for switching to native executables. You're trading off runtime performance for build time performance with that ahead of time compilation. So our build time's gone up from 9 seconds to 194 seconds. It was 215, I remember, in that image, but there's some variability there when you run it. but it's roughly going to take a while. I don't think we're ever going to get it to like down to 9 or 10. So this is probably isn't something you're going to run every day on your workstation when you change a line of code. You might push it out to the CI pipeline instead. The key metric we often use is RSS. It's that all the memory the thing is using. So just running PetClinic regularly on JDK, 417 meg, but with the native image you see we're down to 100. And that's, I'm only saying there that we're down to 100 right now. We're not finished by any means. There is some way to go. And startup time, yes, it's down from 2.6 seconds, which isn't too shabby, down to 158 milliseconds. I didn't show the executable size here. It's difficult to compare because the fully packaged jar is one thing, but doesn't include a JDK, whereas the JDK is included in the native executable. So they're a bit more difficult to compare. And while we're on the subject of figures, let's look at some other numbers. So here I'm comparing roughly where we were Spring 1 last year with where we are now for a couple of samples. So the command line runner I just showed you, that very basic app, used to take 90 seconds, now it's 50 seconds. And these numbers are improving not just because of work we've done, it's work the GraalVM team have done as well. The executable size is down by half. The memory's down by 17%, down to 24 meg. We've had bigger impact on these web apps, whether you're using Netty or Tomcat. See the build times down from multiple minutes to just over a minute. And in Tomcat case, it's down for 3 minutes 20 to just over a minute, down 67%. And you'll see numbers like the executable size for Tomcat's down from 105 meg to just 42 meg. And that's work we've done like that Tomcat programmatic that you saw before. And the memory's down. Yes, look at the Webflux Netty one. The RSS memory's down from 95 meg, another 50% memory saved to 47 meg. And as I say, this is just where we are right now. We have some other things in flight. Sebastian's going to talk about some of them that may make these figures look silly next year. Now, Spring GraalVM Native understands the Spring ecosystem, not all starters yet. So there may be, if you exercise a starter we haven't got to yet, or if you're using a third-party library we haven't got to yet, you may need to add additional configuration for those to work properly. And that's perfectly fine. There is a way to statically provide configuration for libraries and things inside your project. And you can use that as well as Spring GraalVM Native. The two things can work well together. And the way you do this, it's heavily covered in the GraalVM documentation, but the basic premise is that you create a folder, meta-inf native image. This is where Native Image Builder will look for these things. And you create some well-known files in there, one for resources, one for reflection, one for proxies. Just as a sample, we've got the resources one here, and you'll see it uses wildcarded patterns. And this means that anything that matches that pattern on the class path will be included in the image and available for someone to call get resource on. Similarly, the reflect one, you're listing types you need to reflect on at runtime, hopefully down to the member level, because the more accurate you can be, the less waste there is in the native image, executable at the end of the day. Proxies, the proxy configuration lists groups of types that need a JDK proxy so that the image builder can build that proxy up front and include it so you can access it at runtime. Now, manually creating those is a painful job, and it is because of that round tripping. The build times is quite long, so you wait that 3 minutes for a build. It will crash with an error. You'll look at the error, make one change to your JSON files, and then you'll have to repeat that cycle, and it's quite painful. Thankfully, there is a better way. So the GraalVM team supply something called the tracing agent, and it assists with generating these files. Basically, you run your application on a regular JDK in Java, and you attach the agent specifying a place to dump out these files. And then as your application runs, it will observe what is going on, and it will notice you're making a reflective call or accessing a resource or accessing a proxy, and it will produce the JSON for that. Okay, now this weird property here, why do you need that? This is a property that is set when executables run so that you can check on it and see if you are in a GraalVM native environment. And so you can write code today in Java that can check this property and go a different way if you find yourself in a GraalVM environment, maybe work around something that GraalVM doesn't support. So it's quite important to set it at the time you collect the config as well, because those are the code paths you want to be driven when you're using the agent. You only want the reflect and etc. configuration related to those. Now, the agent last year was not in a great place. It was missing things, forgetting to escape things, and you pretty much had to manually tweak the output before you could actually consume it. But working with the GraalVM team, they've done a lot of work on this, and it's in a much better place than it was. And you can typically just use it now, and that output coupled with Spring GraalVM Native, they can work together, and we see a lot of more success with applications using them together. So you might think, okay, I'll just attach the agent and run all my tests. And on paper, that makes sense, but you have to imagine that what's going to happen then is all your test infrastructure is going to generate configuration that's also included in the native executable. You don't want that. So thankfully, the GraalVM team added a access file filter file you can specify. That includes patterns that match against types, and if they match, then they are filtered out and not included, so that you can skip including your Mojitos or your JUnit infrastructure that's reflecting on types. Now, how to use all this? We have docs in Spring GraalVM Native for this. So if you want to read out how to use this in anger with a Spring app, have a look in there. But as I say, if you raise a bug against our project and you're using something we haven't tried yet, a starter or a third-party library, we will likely come back to you and say, why don't you try the agent to collect config for that, combine it with our project, Spring GraalVM Native, and see if that works for you. It may not give you the most optimal image, but it will give you some kind of image as a starting point to work on. And I showed you some numbers, but if you want to follow up with more numbers in the future, you can go and check them anytime. Every day we run all our samples against the GraalVMs that we support and the GraalVMs that are coming down the pipeline to catch anything early. If they break us or we break them, it enables us to get on top of that. But all those build logs include performance numbers, so we can keep an eye on how things are working, both Java 8 and Java 11. Just before I hand back to Sébastien, I want to show you how easy it could be to contribute to Spring GraalVM Native, if that's something you're inclined to do. It may sound complicated because it's native image executables, surely that's complicated. But actually, capturing this JSON and working out the right JSON that support things, it's not that hard. The tools are there, like the tracing agent. So Spring GraalVM Native, at its core, there is an analysis engine for Spring apps, and it understands Spring basics, like how configurations refer to each other, or how conditions exist on auto configurations. But there's no way we could make the core understand the whole portfolio. That would be crazy. There are expert teams in all those areas, and we can't match that expertise just in our little team on this. So there are two ways you can extend this core. Statically, you can capture something called hints. I'm going to talk more about those in a moment. And dynamically, you can write plugins for Spring GraalVM Native. So the Spring Data team have written one. You can imagine that there are certain kinds of component that are important in the Spring Data world, and they may lead to certain proxies needing to be created. But exactly what that proxy looked like may depend on the particular name of that component. So it's not something you can declare statically in a string or anything. So they've written a plugin that understands all that. So we don't have to worry about it as core maintainers of the project. They can look after that plugin. And we expect to see other groups providing plugins for their portfolio projects too. But back to that static stuff. We used to have big JSON files in our Spring GraalVM Native project. Every time we added a sample, we added more JSON. And there was a point when all the JSON in the world was in our project. And we found that it meant every new sample was causing all the samples to suffer because they were all sharing the same JSON config. And really, they needed an optimized chunk of it, just the bit that concerned their application. So we needed to break it down, make it more modular. It was also impossible to reason about this giant file. After 3 months, you would go and look at an entry in it, and you would have absolutely no idea why that was there. You didn't know if it was safe to delete it or not. And so what we did was we broke it down into annotations, Java annotations called native image hints, much more modular, much more type safe, because we're using type references rather than string references. And these hints are attached to a trigger, and the trigger may be that an auto configuration is active or something exists on the class path. And then it's the job of the core engine, really, to work out what triggers are active. Then once it's worked that out, it activates the relevant hints. What does one of these hints look like? It's capturing exactly the same information that's captured across those JSON files, just in a way that's easy for us to reason about. Here is one that's triggering on R2DBC auto configuration. So if R2DBC auto configuration passed its conditional on class check, that means it's active. Therefore, we trigger this hint, and this hint says, I need a proxy for serializable.class and interface foo.class. So JDK proxy will be built and included in the image. with these type references, if someone upstream changes the name of interface foo, this project will fail to compile because of that reference. That's different to if it was hidden in a string in a JSON document. Also, we have type info. Anything you can express in the JSON can be expressed here. Type infos is for capturing reflective information. So we've said, okay, we need reflective access to embedded database, and we need to be able to load and construct it. And this access is quite important because we're specifying exactly what we need and no more. So we're saying we need to be able to call the constructors on an embedded database. That means we don't need reflective access to the methods or the fields, just the constructors. And as I say, it's very important to try and constrain to the minimum set that you absolutely need for your app to run. And you capture these hints on implementations of native image configuration, and then they're pulled together and loaded via a standard Java service loader mechanism. And then in 3 months' time, when we try and work out why on earth is embedded database being included in the image, we can jump in here and say, oh, it's because of DBC or configuration. That is so important that these are easier to reason about. So if you want to help us, there's lots of docs on our project page on this, much more detail than I went in today. It also goes into that interface that Spring Data guys are implementing with their processor. And we'd love to see contributions. If you have a favorite starter you want to get to grips with, if you've computed the JSON and you want to turn it into hints and send us a PR, that would be great. So with that, I'm going to hand back to Sébastien, who's going to tell us about the really cool stuff coming down the road.
Thanks, Andy. So yeah, we are going to talk a little bit about the future on our roadmap. So in December, we will release Spring GraalVM Native 0.9. That's a pretty important release because that will be the first one with the beta status. It will be based on Spring Boot 2.4.0 and GraalVM 20.3. We will support a subset of the starters, obviously. Breaking change will happen, but we will provide documented upgrade path for you. We will provide wider support, so Spring Security and Spring Batch will be supported, and we will also improve the development experience, providing a development-oriented container image where you can debug with GDB, for example, your native image and more development-oriented tools. More starter will be supported in the upcoming 0.9 patch release. So you can expect that between today and December, the support will be increased, but also during the next year, we will continue to increase the scope of the support using what we add and also what will be contributed by the community. So let's now talk about functional bin registration. This is an hidden gem that has been in Spring Framework since 5.0, but not really widely used in Spring Boot yet. Concretely, I guess you use that in your application, and Spring Boot is using that everywhere. We have aConfiguration classes that declare your bins with annotation. And that's how you configure a new bin. That's how Spring Boot is configuring the whole GVM ecosystem. That's very easy to read for a human. That's a very nice programming model. But for a compiler, it's pretty hard to understand by a static analysis what will be done. And basically, native image compiler don't really understand that out of the box. That's why we do all this work to teach it how to interpret our code base. But what if we would provide bin generation and bin declaration in a way that the native image compiler could understand out of the box? That's what allows functional bin registration. So you declare an application context initializer, and on the application context, you will call register bin with some lambdas. And this kind of code is natively understood by the native image compiler. Obviously, we don't want you to change your programming model. You will keep using aConfiguration, but there may be other ways. One way could be to automatically convert aConfiguration to functional configuration. That would apply to Spring Boot auto configuration, and that would also apply to your own application. That would be an automated transformation from configuration to functional configuration at build time. And the good news is that we are working on that for more than 1 year. So thanks to Dev Sayer and also to you, Andy, for creating this Spring Init project. So Spring Init is basically an experimental project that we use in our GraalVM supports partially in an experimental way for now. And it converts the aConfiguration model to a more programmatic functional constructs. It provides also other kind of build time transformation. There is, for example, a Maven plugin that you could integrate in your application to do this kind of transformation, including on the GVM. And so that's what we are using in an experimental way. It's important to show you figures. So we have this WebMVC Tomcat sample, which is the regular Spring Boot application with Spring MVC, Tomcat, and Jackson. We have shown previously that we have a memory consumption, total memory consumption of 51 megabytes. And you see that it's only 26 megabytes using this kind of configuration. And this is all build-time transformation. So while you don't talk about transforming your programming model, it's automatic transformation during build time with huge gains, because basically we don't have to specify reflection configuration for the native image compiler. And also, it's not just about figures. The compatibility is improved because we don't have to add specific ints to get support for native images. It's provided out of the box. We plan to experiment more on build-time transformation. So in addition to this configuration transformation, we plan to try to infer proxy bins method equal false in order to not require you to change your Spring Boot application. And also, you remember this kind of flag like removing spare. We could maybe analyze your application and its dependencies, see if spill is used, and if it's not used, we will set this flag automatically at bit time. So this is the kind of optimization we would like to work on. Like said in the keynote, Spring Boot 3 based on Spring Framework 6 is expected to provide first-class support for native application deployments as well as an optimized footprint on the GVM. We will share more about that in the upcoming months. We are coming to the end of our talk, and I would like to share with you a few takeaways. So the first one is that I think Spring Boot native applications are great to build lightweight containers and are a good fit with Kubernetes. You can try it now with our Spring GraalVM Native support. The 0.8 version has been released. We are looking for contributions, so feel free to send pull requests for your favorite starter. We have a related documentation for that. The beta support will start as of December on a subset of the starters with Spring GraalVM Native 0.9 using Spring Boot 2.4. And wider support and smaller footprint will come during the 0.9 patch releases. Upcoming first-class native support will be available in Spring Boot 3 and Spring Framework 6, but really you don't need to wait Spring Boot 3 to benefit of that. We will make it possible to use those improvements as part of the Spring GraalVM Native and with Spring Boot 2.4 and maybe the next releases. You can have a look to this Spring GraalVM native repository on GitHub. We will publish some blog posts with Andy in our blog, and you can follow my Twitter handle for more fresh news. Thanks for attending to this talk, and I think now we are going to answer to the questions in the Q&A session.
Thanks so much, Sébastien and Andy. Native images are certainly a hot topic, and I thought that was very informative. As always, if you have questions for Sébastien and Andy, hop on into the Q&A session by clicking the Zoom link on the breakout session page. We're going to take a short break, so go ahead, grab some coffee, stretch your legs, and don't forget to meet us back here in a few minutes to learn about the best way to build Spring app images.